In this video, we're going to prove many of the properties of the norm of a complex number. Remember that if we are given a complex number, z equals a plus ib, with ab reals and I squared is minus 1, we define the norm of z as the square root of z times z bar, with z bar is the conjugate of z. Okay, so now we're gonna prove many of the results that we need. So one of the results that we're gonna need first is that what's the norm of two complex numbers? What's given z1 and z2, what's the norm of z1 times z2? Okay, so if we square this one and apply in the definition here, we get just the z, which is z1 times z2 times its conjugate, which is z1 times z2 bar. Okay, so again, z1 times z2, and we know that the conjugate of the product of two numbers is just the product of the conjugates. So we have z1 times z2 bar. And since C, the complex set, is commutative, we can move Z1 here. So we get Z1 times Z1 bar times Z2 times Z2 bar. And this is what? This is just Z1 squared times Z2 squared. By definition, not here, using this one here. The same thing for Z2, using this definition. So taking the square root, again we get z1 times z2 is z1 times z2. So we have proved that the norm of two complex number is just the product of the norms. This one will help us prove one of the first result. Okay, so we will prove that the norm of 1 over z is just 1 over the norm of z. Okay, so that's one of the keys that we can use to prove our result. So we use it here. So let's think of z1 as z and z2 is 1 over z. So we have z. Okay, let me use another color. Maybe I have another color. Okay, here I have this red here. Let's use this red here to make it more clear. So we have z times 1 over z. Okay, so this is just a norm of 1, which is 1, assuming that z is different from 0. So what do we get? As according to here, the result that we proved here. So we get z times 1 over z equals 1. So dividing both sides by the norm of z, we get the norm of 1 over z is just 1 over z. Okay, so now we're going to use this same result to prove that the norm of z1 over z2 is just the norm of z1 over the norm of z2. Okay, so we can write z1 over z2 as z1 times 1 over z2. And using here this result, we get the norm of z1 times the norm of 1 over z2. Okay, and now what's the norm of 1 over z2? Is using this result here is just, this is z1 times 1 over z2. So we proved here that the norm of z1 over z2 is just the norm of z1 over the norm of z2. This is very important result that we can use in many different applications. Okay, so now we can use this result to see what's, or maybe this one here, to deduce more important results. So what if we have z1 equals z2? What do we get? We get z times z, which is z squared, equals what? Equals the norm of z times the norm of z, which is the norm of z squared. Okay, here. So now if we have n numbers, okay, so z to the power n, according to our definition, with n an integer, is z times z times z and time, okay? According to this definition here, so this is the norm of z times the norm of z times the norm of z and time. But this is just z and times. So we have proven that z to the power, the norm of z to the power n is the norm of z to the power n. Okay? Again, we need the concept of mathematical induction to prove this result, but from here we need to get this result here. This is very important to have in our mind, because solving many problems will rely on this one. So when we have z is 2, we are here. Okay? Okay? When you have z is minus 1, we get here. But the most important thing is to know how to apply them and how to prove them using the definition of the norm. Another thing that I wanna mention, I don't know where I put it, is that to prove this one here. So this is the one that is I will come back to it. So I'll come back to do more problems, more definition about the properties or the elementary operations on the conjugates. So we need to have one more video on this. Besides that, I think we defined the conjugate, defined the norm, and we defined the norm of two numbers, the norm of the quotient of two numbers, and the norm of the inverse of a number, and the norm of many n numbers. So this result will definitely help us solve more problems. Okay? Thank you very much.